Hey, Cal kids, so let's use Desmos to create a line that is tangent to this little spiral curve over here. And this is the parametric equation. That's the parametric equation for this curve. This is the x-coordinate of any point on the curve, and this is the y-coordinate. And you can just make this stuff up, or if you find something like I found this curve, it's called the circle involute pedal curve. And here is the parametric equations for that curve down there. So I just did it. But maybe it should have been that one. Anyway, let's go back here and play around with this a little bit more. So I've got this curve over here, but what I'd really like to do is I'd like to place a point on the curve. So I'm going to make a slider. I'll call the slider a W, and I will set the slider starting at 0. And since our t values for our parameter go from 0 to 2 pi, I'm going to do the same thing here. I'm going to go from 0 and I'll go to 2 pi. And I want my step size, just like we saw yesterday on the Inspire, I want my step size to go from pi. And I literally just type in the word pi divided by 180. And so that means it's kind of going to move by like 1 degree steps, if you will. Now I want to make a point. So when I drag the slider, that point will move along the curve. And so I'm just going to rewrite this thing down here, but I'm going to use W's. So W, sine of W, and then negative W, cosine of W. And so there is the point, and let's make that point bigger. So I long press on that dot, and I'm going to change the size to say 15, and maybe I'll change the color to like a purple color. And maybe I'll change the style to like an open dot so we can see where it is. So as I drag my slider, that point moves all the way around that curve. And so what I would like to do is I would like to write the equation of a tangent line at that point. So the first thing we'll need to do that is we're going to have to find the derivative of this set of parametric equations. And so I'm going to go start with a fraction bar because the numerator is the derivative of the y coordinate. So it's going to be the derivative of this, but I'm going to place w's in it. So I'm really going to take the derivative of this, but I'm going to use w's in it so the slope will change relative to this point. If I use t's, I'm going to make a graph. I don't want to make a graph. I just want to make I just want to get a number that will change. So I'm going to use the product rule to take the derivative of that puppy. I'm going to use the product rule. So the derivative of negative w is negative 1 times the cosine of w. And then I'm going to go plus negative w times the derivative of cosine, which is negative sine. I'm going to put a w in there. And I don't need to simplify that because it's going to work out. Now I'm going to do the derivative of the x-coordinate. So the derivative of w is 1 times sine of w plus, then it's w times the derivative of sine, which is cosine. And I'll put the w in there. And so notice that changes when I'm up there at the top. That number changes. And when I get right about there, it should be close to 0, and it is. And when I get over here, like at that point, it should be really, really big, probably close to infinity, but it won't ever get there because we're just going in little steps. But you can see the slope is very, very steep there. And so let's write the equation of the tangent line. So it is y minus the y-coordinate, which is negative w times the cosine of w, equals the slope. Well, I don't want to copy that whole thing, so I'm going to go here to the front of it, and I'm going to go m equals, so I'm going to grab the slope. And so y minus the y-coordinate equals m times x minus the x-coordinate, which is w times sine of w. And so there it is. As I drag my slider, that tangent line moves along with it. That looks cool. That looks very, very cool. So that's why I can use Desmos. You can do the. It's a little bit more challenging to do that on the Inspire. It's way more easier to just to either use your iPad or grab a laptop and do it. But that is how I would make a parametric equation and then a parametric point that moves along the graph of this parametric equation by using a slider I named W. And then I found the slope. And then I wrote the equation. And I didn't simplify anything. I just wrote them down. So give this a try.